All right, guys, thanks for tuning in here today. Today we're going to be working on creating a radar chart. So, a radar chart is what you see down here. When I see this, I think of like a personality test or something like that. But it was requested a couple times on Reddit, so I figured that I would go ahead and create this. But this is definitely an in-depth one, and it's going to take some time. Okay. So let's go ahead and get started. I am going to be copying and pasting pieces from this code over. Okay. So I'm going to start by creating a new project, and I'm going to create a single view app. I'm going to call it code tutorial underscore radar chart. I'll put it on my desktop, new folder. That's fine. Okay, so the first things first, I want to create a new view here called a radar chart. So new file. SwiftUI view, radar chart view. Okay, and there are definitely some tutorials out there where they show how to create this using Geometry Reader. I actually don't really like using Geometry Reader that much. I try to avoid using Geometry Reader as much as I can. Just because I feel like I can achieve everything without it, and I think things are much easier to animate outside of it. If you have a different opinion, please feel free to let me know below, and you can even show me some examples online of people who have used Geometry Reader to create some things that you thought you couldn't create without Geometry Reader. So let's go ahead and start creating this. So the first thing we're going to do is let's open two of these windows side by side. I'm going to get rid of this right here. I don't need that. I'm going to get rid of the left navigator. Okay, and I'm going to actually open up a new pane here. And then I'm going to close this, and on this side I'm going to open up the content view. Okay, so my goal here is to create a radar chart that I can reuse over and over, and I can just call it as radar chart. So if you look in the other project that I worked on, the way I use it is I literally just declare a radar chart view. I give it a width, I give it main colors, I give it a subtle colors, kind of like this very bright white and this kind of darker gray or light gray. Then I tell it how many dividers I want, so 1, 2, 3, 4. So I told it 4. I tell it how many dimensions there are. So this is 1, 2, 3, 4, 5, 6 dimensions, and I give it the data to create the polygons. Okay, so we're going to be creating it this same way. I really like the way that I can just open content view and execute one like this. You do have to create the data that's going to go in, but of course, you're going to obviously have to have the data that goes into what you need. So let's go ahead and do that. So first things first, let's go over to the radar chart view. And we need to create some structures here. So I'm going to just bring this over here for a little bit. Okay. And inside of our radar chart view, we need to create a few things. I need to create something new called ray cases. Okay. It's going to be a new enum. Okay. So I'm going to grab that. I'm going to bring it into our project that we're working on together. So I'm actually going to put that over here inside of content view. Okay. Things that need to be changed each time you use radar chart, I'm going to put on this side, and things that are constant in radar chart are going to end up over here. So, and over here is the radar chart view file, and this one is the content view file. Okay, so for enum ray case, I'm essentially saying that it's going to be a string, and it's a string that I can iterate through. So it's called case iterable, and I want it, so that'll let me run through each of these and get the raw value. So I chose the following attributes. I chose maybe intelligence, funny, empathy, veracity, selflessness, authenticity, and boldness. So you can create anything you want here. But the biggest thing is this is the case that you're going to use for the enum, and this is the string that you're going to use. And when I say the string you're going to use, I'm referring to the string that will show up here on the labels. Okay, so this technically can be anything you want. You just have to refer to it over and over. But the one that's going to show up on the screen will be the strings here. These are the raw values. Okay, and make sure it is case iterable like that. Okay, so now that we have that, let's go over and look at the radar chart the radar chart view file, and I need to create a new structure called a ray. Okay, so I'm going to bring it over here, and we'll talk about what's in it. So a ray needs to be identifiable. I actually make all my structs identifiable, and I don't really see a problem with it. If anything, if I want to loop through them in a for each, it makes things easier. There are times when I actually have to make them identifiable, but in the given case, I don't have to. I just chose to. I give it an ID equal to UUID. I give it a property that's a name, that's a string, a maximum value, that'll be a double. Okay, and I'll give it a ray case, and it'll be of type ray case, which will be one of these. All right, and the initializer is important. The initializer is going to have a max value of max val. This is going to link to that. Okay, And then we have ray case. And when you feed in ray case, that'll actually auto-populate the name as well, because it'll be based off of the raw value of this enum string. Okay? So let's go to the next piece we need. We're going to need a ray entry. Okay? And so let's grab this. So where do we use a ray entry? A ray entry is actually going to be part of the data points. So for instance, if you have a data point of a person, each one of these attributes is going to be a ray entry. So you'll see how we use that in a moment. So I'm going to go over to this file. Okay, so this is the one we're working on together. Okay, the radar chart view, and underneath the struct for ray, I'm going to have ray entry. So I'm going to, sorry, I needed to grab it from over here. And it's going to have two properties. It's going to have ray case, and that'll be of type ray case. And it's going to have a value, which will be equal to double, or of type double. Okay, and I'm going to create a few functions here. All right, I just need to be able to convert degrees to radians. That's the first one I want. I want to be able to get a degree angle from a fraction, so I'm going to give it a numerator and denominator. Okay, and I'm going to be able to convert that fraction to from degrees, the angle from degrees to radians, and that's just literally converting the output of this using this degree to rad function, and spitting it out as a CG float. So I would just pause and copy these three functions. Okay, so I'm going to put those right here underneath ray entry. Okay, so those are going to be used over and over. Okay, and then the next thing I'm going to do is I'm going to grab a couple variables that we're going to need to have for the actual radar chart view. Okay, so I'm going to put them. These next ones are going to actually. So I'm going to fold the code for all of these structs that we just created. These reusable items. Okay, and now I'm actually working inside the radar chart view, but above body. Okay, I need a main color of type color, a subtle color of type color, a center point. I need a label width. Okay, I'm going to have that standard size of 70, but you can change that to whatever you want. Then that is essentially just dictating this width. Okay, the width of these. And then this width refers to the overall width of this entire container. So pretty much from right here until right here. Okay. And then we have quantity of incremental dividers. That's essentially the number of each of these kind of steps out that we can have. We don't necessarily need them there. And then we have dimensions. And so that is going to be the array of all the different angles, or all the different kind of paths that we can, or attributes that we can track. And it's going to be an array of rays, and we'll have data, and it's going to be an array of data points. So now we need to add the struct for data points. All right. So let's go over here. Let's grab that next piece. So the struct for a data point. I'm going to copy that over. That is going to go inside of our content view. Okay. So the struct for a data point consists of an ID, UUID. It's going to be identifiable. All right, and it's going to have all the entries. So this data point might refer to, like, let's say, a person, and each entry in this, each ray entry in this array of ray entries, essentially is one of the attributes of that person. So when we init this, what's important is that you need to make sure that so my initializer here is essentially taking, I'm creating all these parameters: intelligence, funny, empathy, veracity, selflessness, authenticity. Okay, we actually don't need, I'm not using boldness anymore, so I'm just gonna leave it there, but I didn't end up using it. So it's taking each of these parameters, and whatever value I put in, it's creating a new entry, a new ray entry inside of the entries array. Okay, and that entry, it's going to have a value of whatever value I put into the initializer. Okay, and you also have to pick a color when you initialize each data point. So that color for this one, we'll refer to this green, red, and blue. Okay, so now we have the data point here, so it can't tell me we don't have that anymore. Okay, and then the next thing we'll do is we'll set up the initializer for the actual radar chart view. So I'm going to grab all that. Okay, and we'll talk about each one of those parts as well. So inside the initializer, what we have, well, I'm going to actually get rid of this radar chart previews because we are never going to use this. I don't feel like setting up sample data for it to get made in real time. So inside of this radar chart view, what we're going to, for the initializer, we're going to essentially initialize it with a width, a main color, a subtle color, a quantity of incremental dividers, dimensions, and data. So essentially all the things here. The only difference here is that we need a center point, and we are grabbing that center point from the width. So our center point is going to be equal to the width over 2. And we're going to say that this view itself always has to be square. So when this says width, it really should say size, because it's going to be a square view. So let's go and look at the next piece. So right now, I have show labels, and we're going to copy it over, and we can maybe even set it up at the end if we decide to. And that's a state variable that determines whether or not this is going to be showing the proper labels. All right. So now we're going to get into the meat here, the meat of this this view. So I tried my best to label it as best I could, okay? But essentially, this is a bunch of paths stuck on top of each other, okay? We have a path for each of these hexagons. We have a path for each of these lines that are like the spokes, okay? And we have a path for each of these polygons. So what I need to do is I need to stack them all on top of each other. So I'm going to have a z stack. That's going to be the first thing inside of here. So z stack, okay? And then let's walk through creating each one of these pieces, all right? So what I'm going to actually do here is inside the content view, I'm going to create my z stack, okay? And inside of that z stack, I'm going to put, if we look at what we had here, I'm going to just put a black background, okay? That's going to be the first thing. And then on top of that, I'm going to put a v stack. And that v stack is just going to have a couple things. It's going to have my text that says radar chart at the top, okay? I understand that this is kind of folded over and it gets confusing what's on this line, so I'll open it up for you just so you can see. But we're trying to do as much as we can without opening up the left-hand side. So this VStack in the content view is composed of a text that says radar chart. It's composed of the actual radar chart view and a spacer that shoves everything to the top, okay? And it'll have a foreground color of white, which we'll toss in there too. So let's go back to the project we're working on together. Okay, I'm going to give this whole thing a foreground color of white. Foreground color of dot white. Okay. And so it's giving us a couple errors. It's just saying we haven't told it what the dimensions and data are yet. That's okay. We'll get to that. So now we're going to look back at the Z stack. Okay. The Z stack, this is now the Z stack inside the radar chart view. All right. And so that Z stack is composed of a couple different things. Let's go back. Okay. And this is now the radar chart view. This is where we're grabbing from. I know it can get confusing the way I have this opened up, but it was the easiest way to not have to use the navigator, and that was my goal. So the first thing we want to do is we want to create the main spokes. So let's copy that over and discuss it. So the first thing is creating the spokes. So we're going to create a path, okay? And we're going to loop through all of the dimensions that we dictated. So we are going to feed in dimensions from our, in the content view here, we're going to feed in a set of dimensions, and the dimensions are equal to the following things. They're essentially just all the different ray cases. So intelligence will be a dimension, funny, empathy, all these will be a different dimension. So what we're doing is we're running through all the different dimensions, and we are getting the angle at which they will essentially create the spokes. So this will be at 0, and this one will be at 60, 120, 180, 240, 300, and back to 360, but there's no 360 because it just restarts, right? So what this is it's looping through all the different dimensions, it's counting them, and it's setting the angle. So it's using one of these functions above, so it's getting the radian angle from the fraction, and it's checking, it's saying the numerator is our index within the list of dimensions, and the denominator is the dimension count of how many there are. So essentially, if there are 6 dimensions, it's saying that we want 1/6 of 360 degrees, and it runs that through this function here, rad angle from fraction, and it's creating the degree form and then running that through the degree to rad. Okay, so this is essentially just getting the angle for each of the spokes. Okay, and then we're taking that angle and we are multiplying this right here. We have let x equal, so we're getting the x dimension. This is just basic trigonometry. So we're saying how, what is the x dimension based off of the cosine of the angle. So we're taking the cosine of the angle, okay, and then we are just multiplying by self.width minus, okay, minus 50 plus self.label width, okay, so all of this over 2, okay, and the reason we're doing all of this over 2 is because the width would have taken the entire radar chart all the way to the edges of the screen, right? And then the 50, we're saying minus 50, so just bring it in 50 pixels, okay? 50 total, so 25 on each side because it's divided by 2. So we're giving it 20, essentially it's a padding of 25. So we're bringing it in 25 on each side for the sake of padding. And then we have self.labelWidth, and that's going to make room for the actual labels. So that's what you're doing. You're saying make it as big as the width minus, just a tiny bit of padding, 25 on either side, plus the actual label width. So that's the point of that's the point of this expression here, okay? And then you're multiplying, so it says over 2, right? And so you're taking that and you're saying times the cosine of the angle. So cosine and sine, if you don't know much about that, that's just basic trig, but I would venture to guess that most people in the programming world are fairly familiar with math. So from there, we're essentially saying run through it and move the path to the center, okay? And then draw a line all the way out to the end of the spoke. So whenever you see path.move, it's like lifting up your pencil and moving it somewhere. And then when you say add line, it's like putting it back on the paper and dragging it, okay? So that is how you get that function, that area is just how you get all these main spokes, okay? So you're going to see a lot of repeating pieces in every one of these. So that path, we can literally fold that up now, and we can just say, this is how you create the main spokes. Okay, or even just, I'm just going to write main spokes, okay? And then that path, so the same way you can take a circle and take the stroke of it. So that path, we're going to say for each of those paths or lines in the path, we want to say dot stroke, self dot main color. So this can be whatever color you dictate. The stroke style, I gave it a line width of 2. I gave it a line capping of round. That means the ends are not squared off; they're rounded, and the line joinings are round, so they're not sharply connected. Okay. So that's the first piece. That's the main spokes. All right, what's after the main spokes? Let's see what we got. Next is we want to create these labels, okay? And you'll find that most of these pieces are all pretty much the same thing over and over. Okay, so I'm gonna have labels here. So I'm gonna say labels. Okay, this was just junk I was testing out, but we didn't end up keeping. So let's check what it says. So we're running through once more. We're saying for each, the same way we ran through the for inside, okay? The difference between for and for each is for does not return views, whereas for each does, okay? So you have for each, and we're running through each of the dimensions, and we're writing out the text of that dimension. So we're saying self.dimensions, dimension I, we're getting the array case of it in the raw value. So we're essentially creating a text with one of these values right here, okay? And then from there, we're giving it a font size of system 10. We're giving it a color of whatever you chose as the subtle color. And then its frame, its width, will be exactly equal to label width. So that's important because whatever you chose to make label width up here will dictate how much space you're giving the labels inside of here, because that number is also scaling the size of this actual radar view. It's scaling it, if you remember, right here where it says x is equal to self.width minus blah, 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 blah. But notice it says self.labelWidth. So close that back up. And so that tells us the frame, which is giving a frame height of 10, but that's kind of arbitrary. I could have picked anything really. And then the way I'm doing it is I'm actually writing them all out here, and then I'm rotating it up, okay? And then it's rotating accordingly, the same way that these spokes are being rotated, or the endpoints of the spokes are being rotated. And that's how I created everything. I thought it was kind of one of the smoothest ways to do it. But one thing that you'll find is a snag is that technically, if I were to keep rotating this, right here, this text should be upside down, okay? And this one, it should be almost upside down. This one's entirely upside down, and this one's starting to rectify itself again. So what I did is I added a little piece here. I said that I'm going to rotate it, and I'm going to say that if the item is anywhere from here to here, then it will be on the verge of being upside down, or more upside down than it is right side up. So that conditional that you see right here, this ternary operator, I'm saying that I'm going to add a rotation effect of dot degrees, okay? So a rotation effect of angle. What kind of angle? I'm going to give you the angle in the form of degrees. And what I'm checking is I'm checking if the degree angle from fraction. So this statement right here is essentially checking, are we between 90 and 270 degrees? Okay, which means am I from here to here? And if I am, then actually flip the entire text 180 degrees. And that's how, instead of being upside down, we just flipped it right back. So we use the ternary operator to do that. So that's what this line right here is doing. We're flipping the text back in case it was going to look upside down, okay? And so then here we give it a background color of clear, and its offset, was equal to self.width minus 50 over 2. The reason we did that was because by default it's in the center, so its center is in the center. So I told it offset by self.width, which brought it all the way here, okay? And then, if you remember, I accounted for a padding of 25. So I brought it out all the way there, okay? And that's how we got it to look the way it does. So, then at the very end there, I gave it the final rotation. So this inner rotation, this one right here, this rotation effect here, is just rectifying the upside down, whereas this rotation effect here is just rectifying, or is not, I shouldn't say rectifying, it's actually setting the actual rotation. It's making sure that this is in line with the line that it's corresponding to, okay? So I'll save that. We'll make sure we save it, okay? And then let's look at the next piece. So that gave us our labels, all right? And that's that. So there's nothing new there. Before we keep going, actually, I'm going to go ahead and copy my sample data over. So right now in our project, you have our enum for array cases, okay? You have our struct for data points, okay? You have all of the stuff we needed, overhead stuff like the arrays, the array entries, all these functions. But what you don't have is data and dimensions, okay? So data and dimensions, don't be fooled, even though one of them, if I remember correctly, so if you look at it, actually both of them are arrays. So this is actually your data, okay? So these dimensions, I'm going to copy mine over and we'll talk about what it looks like. So I'll put it right here. My dimensions are essentially just the various arrays. So I'm going to say one dimension is a array of case empathy and has a max value of 10. Okay, and funny has a max value of 10 as well, and intelligence and veracity and selflessness and authenticity. But the power in doing it like this is that I can actually give each of these a different maximum value. You know, I can make something binary, 0 or 1, or I can make something else have a scale of 1 to 100, and it'll scale properly inside of the final product. So this is not 10 here, 10 here, 10 here, 10 here, 10 here, 10 here. It only is in the given case because I said the max value for every single one of those attributes was 10. But I can make them 20 and they would scale accordingly for that specific dimension, okay? So we're back, this is the one we're working on together, okay? If you get confused, we're working on the one that says code tutorial _ radar chart, whereas this one says radar chart trial. So don't get confused between the one I made in advance, which is the one that says trial, and the one that is code tutorial. That's for us to work on together, okay? So I copied my dimensions over, and the biggest thing is your dimensions here, these array cases, you need to make sure that whatever array cases you want here, you have the same array cases here, okay? Because these are what allow us to populate the dimensions, and these texts are actually what set up, remember, those are what set up the labels here, okay? So the next thing I'm going to do is I'm going to add my data, okay? So I copy my data over, okay? In my data, for each one, I just created a data point, and I gave it, if you remember, my initializer lets me give it, I'm going to close up the dimensions so we can look at that. So actually, I'm going to move the dimensions up top on top of the data point structure, and the reason I'm going to do that is because it's going to be next to the relevant enum, just like this struct is now next to its relevant data. So data point, okay, I can initialize it with an intelligence value, a funny value, an empathy, veracity, self, authenticity, and color, okay? And I give it, when I give it the color, that dictates the color that'll show up right here. So I just chose the following data points. I made a couple of those, and that's that, okay? So now that I have my, my data in there, I can actually hit resume, and I should be able to see this updating in real time now as we go. So we can watch this grow together. Okay. Oh, so we got something a little off right there. So we'll figure out what that is as we go, okay? Let's keep moving right along. So, next thing we have here is the outer border, okay? So we already created the main spokes. We already created the labels. Now we need to create the outer borders, okay? And so I'm going to copy that over and we'll talk about it. So, for the outer borders, it looks a lot like the main spokes one, but what we're doing is we're saying the path is going to, we are going to have it start at the center, okay? It doesn't really matter, actually. This one's kind of irrelevant because let's actually just get rid of it since it's irrelevant. So, if we play it again, let's see what it looks like, and we can figure out what it does, okay? All right, there we go. And we'll figure out what's up with these labels in a moment, okay? So what we have going on here is we're telling the path, we're running through the dimensions again, and we're setting the angles the same way we set the angles above. And now the x and the y are actually going to be the same. But the next piece that we have in here is, instead of drawing from here out and then here out and then here out and picking up our pencil, what we're actually saying is, if you're on the first index, bring your pencil right here and then set it down. And then that's what this if I equals 0. And if I doesn't equal 0, that means we're no longer, it says add line, which means we're actually bringing our pencil down to the paper and drawing from point to point to point. That's the only difference, okay? And then we're giving it a stroke self.main color, and that's it, okay? So that's that. And then the next piece we need, so we have labels, we have the spokes, we have the outer border, okay? We need the incremental dividers, and then we'll put the data polygons, okay? So for the incremental dividers, I'm going to copy those over. So I'm going to write outer border. Okay, and I'm going to write incremental divider. Okay, so for the incremental divider now, it's essentially running through the same thing, but there's one extra piece here. What we're doing is, if you look, we're saying we have a for each here, okay? And the for each is essentially we're creating the exact same thing, this exact same hexagon, but we're scaling the hexagon. So if you look at the outer border one, you'll notice that right here, where it said this is the outer border one, and this is right down here, this is our incremental divider, okay? I'll close this up a little bit so we can see a little more on the screen at once. Yeah, okay, so we have the outer border right here, and we have the incremental divider right here. So this piece right here looks exactly the same as this piece, okay? And then the angle looks exactly the same. But now we have something new here. We have size, okay? And size was really similar, okay, to, if you look at size, it has the first component here, this, all that right there looks exactly like this, okay? But what's happening is we have a multiplier right here, and that multiplier is essentially saying if you're trying to add one incremental divider between the center and the outer border, then we're multiplying that size by half, so we get one halfway between. And this essentially, this expression here is it's simply just taking that where we are in this for each loop, it's running through from 0 up to the number of incremental dividers that you wanted. And it's creating the fraction that'll set up each of those scales accordingly. And that's how we get, if I said 4, that's how I get 1, 2, 3, 4. So we put it inside of a for each loop, and we create that many hexagons. And then after we do that, or inside of that, we actually use this size. Now we create size first by doing that multiplication and feed size in right here instead of just doing this right off the bat, okay? But otherwise, it looks exactly the same. So we have if I equals 0, and we have else, blah, blah, blah. And that is essentially the same principle. And I said dot stroke, it's going to be a subtle stroke. And this is the same as above, okay? So that's that. And let's hit resume. Let's see what that looks like. All right, we're getting a lot closer. We'll take care of these at the end, okay? So now let's go over to the finished one again, and let's look at the data polygons. So the data polygons is where we get to have a little bit more fun, okay? So I'm gonna close it up, I'm gonna bring it over. Okay, and we'll talk about each piece as well. Okay, I'm gonna say data polygons. Okay, and so here we have another for each loop, okay? And we're looping through each one of the datas, okay? So from now on, just remember that what we're doing is we're looping through the all the data, okay? And we're doing the same thing to each data point, okay? And each data point, each time we loop through this, we will return an any view, okay? So I don't know if you know this, but you can actually do a for each, and you can say, you can use this j, the same way I use this j, it's just kind of like a variable to refer to in the closure. For the items that you're looping through. and you can actually set a return value. You can actually do the same thing in Geometry Reader. You can say, Geometry Reader, and then open a curly bracket and say geometry, and then set what it's expected to return, and then say in, and then return that inside of the closure itself. So now inside of here, what we're doing is we are first creating the first thing here from, let's just say, from here until the return. This is just saying create the path, okay? And then this right here is just saying, this one right here is just stroke and fill, okay? So the piece I copied over starts from here and ends here, okay? And what it is we have let path equal path, okay? And to create the path, we're running through each of the dimensions, okay? And we're saying this dimension, we are first starting out with dimensions. We're going from dimension 0 all the way until the last dimension, but then we're coming back to the first one again. And the reason we're doing that is just to kind of close the circle, okay? So whatever it does for the 0th dimension, it'll do for the +1. So, if we have 6 dimensions, that's going to be indices 0, index 1, index 2, index 3, index 4, index 5. So this is going to be index 0, 1, 2, 3, 4, 5. And then there's technically a 6th element, but it is not referred to with index number 6. I can't say dimensions element number 6 because that would be the 7th element, because elements in an array start at 0, right? So we're just saying if you get to the 7th element, you refer to it back as 0. That's how you're going to complete the loop, okay? So that's why we have for I. This is the only place, if I recall, that we actually loop through the dimensions up to for I in 0 ... self.dimensions.count +1, okay? It's crucial. I'm pretty sure this is the only point, but if you've been building along with me, you'll know if I'm wrong on that. So what we're saying is the current dimension we're checking is going to be equal to self.dimensions if I is equal to, in the ternary operator, so if I is equal to self.dimension.count, so meaning if we're on one that doesn't exist, then let this dimension equal to 0th one again. Otherwise, just give me where we are inside of this for loop. And then we have let max value equal this dimension dot max value. Okay, so we're checking for the upper limit so it can scale it accordingly. And then we have let data point value. Okay, so let data point value be a double, and it's going to be equal to whatever the return of from here to here. This is pretty powerful. I just learned this pretty recently. I'm pretty self-taught actually. I didn't have any formal training, so I'm kind of learning things as I go. So I found out that you can kind of set the value like this. So I'm saying the value of the current data point, it's going to run through all the arrays inside of the data point, and it's going to try to find the one that matches up with this dimension. So it's going to find what this section here is doing. It's finding the array for instance, for empathy, and it's checking the empathy value of my data point, okay? And when it finds the empathy of that data point, it's scaling it accordingly. So it's saying that the data point value is going to be equal to the value of that data point array, and then it's going to set the angle the way you're used to seeing the angle set, okay, just like above. But then this, when it says size here, this size, what it's doing is it's saying the point, what we're doing is we're setting where this is right here. And the way it sets that is it takes the maximum width, assuming like if empathy is on a scale of 0 to 10, it's saying 10 would be all the way here, and then you're multiplying it by the fracture of the data point's value over the maximum possible value. So if you gave it a value of 5, it'll say the maximum was 10, and so you gave it a 5 over 10, so it's 50%, so it sets the point right here, okay? And it adds that point, okay? And once it adds that point, for the first one, it moves the pencil to that point, and from then on, it continues to use add line to draw that. It's no longer a hexagon. It draws the polygon points, okay, which will eventually create the entire path. So this piece, max val data point, okay, and the way that they get put in right here is what creates the different values at each of these, okay? And so that is how you create the polygons, okay? So let's hit resume. okay? And so that makes plenty of sense, right? Now all of our values are in their proper spots, okay? And then we just have this issue of these labels here. They're not in the right spot. So what we'll do first, we're gonna add this frame of width, and height. The height will also be the width. So when we say width here, remember we're referring to the width that we declared all the way up top here inside of radar chart view. So I'm gonna say the frame width and height of the entire thing is gonna be equal to width because it's a square, okay? And we'll put it right here on that V stack. We'll save it. We'll resume. Okay, and there we go. Once you did that, everything lined up properly. So now we have the labels in the right area with respect to the entire radar view. Okay, and so that is how we went about creating this. So what I'm going to do is I'm going to scroll, I'm going to unfold all this code, okay? I'm going to grab all of it and say Control I. That'll unfold all of it and re-indent everything. It didn't unfold it. It just did re-indent it though. So I unfolded all the code for you, okay? And I'm going to scroll through it slowly, and you can kind of make sure yours lines up. I will also upload the code for you to snag if you would like it. I'm going to do that so it's not folded over, okay? So that's that. But if you're following along and you just want to check one or two spots, this is a good way to spot check. Okay? And then I'm going to go back over here, and you can kind of check out this code too. So let's go ahead and just get rid of this entirely. This was the second page, which for the most part, the content view itself is just this. It's literally just the black background and then the VStack that has that inside of it. Okay? But this stuff up here is important, where you created your enum of array cases. Okay? You created your dimensions array and your data points and your data. Okay? And that all ended with this. All right, so thank you for watching. I know this was a long video. This definitely took a lot of time to make, so I really appreciate you guys checking this out. And if this was helpful, I always appreciate a subscribe. Thank you so much. I appreciate the support. And yeah, if this was helpful to you and you're part of like a Facebook group, please feel free to share it and let people know that this kind of stuff is out there. All right, thank you guys.